Let's continue the system design. Today, I am going to discuss one theorem very famous in the distributed system designs, that is the CAP theorem. These theorems, you can say, are the trade-off between your C for consistency, A for availability, P for partial fault tolerance. So here somehow depend upon the nature of application, you have to compromise, because every times this theorem say if you want your system should be very highly consistent, highly available, and highly partial fault tolerance. So this is the very possible situation. So somehow this theorem say what the things you can achieve and what the thing you have to compromise something. Okay, so let's talk this the theorem and understand what this theorem explain. So this CAP theorem. So CAP theorem also sometime you known as a Brewer theorems. Oh, so what they say, it is impossible for the distribution data storage system. So here they are talking, this theorem is the distributed data storage system where you are storing your data in the multiple node, multiple server. So in this scenario, this is impossible to guarantee simultaneously these all three features. So whatever we are read, the consistency, availability, and the partial tolerance. Okay, so these three are impossible, you can say, not guarantee as a system. Hey, for the distributed data storage point of view, these all three are not possible. This is basic. So you cannot commit all three for the distributed data storage system. Hey, your system is highly consistent, highly available, and highly partial tolerance, partition tolerance. So this partition tolerance, availability, and consistency is the three very key features in the system designs. But this CAP theorem say, hey, how we can achieve and what kind of a trade-off between all three. Okay, so this CAP theorem say, just visualize the CAP theorem as a triangle, So this theorem say, hey, just assume this is one triangle, and these triangles, these all your consistency, this is the one, availability another, and partition tolerance is the another. So here say it's a vertices. So if as a triangle, this any two, like if your system, you can say system can be optimized at most two of these three vertices, not all three simultaneously. So simultaneously you cannot achieve all three, but at least three out of three, two can possible at the same time. So here say, if you want your system should be highly consistent and highly available, it is the possible. If you want your system highly consistency and highly partition tolerance, it's also possible. Or you want to highly availability and highly your partition tolerance available, but all three are not possible. So this theorem just say, hey, whenever you are committing to the customers for this distributed system where you are going to storing your data, in those case you not guarantee all three, because it is not possible for you. So let's talk to the customer. Hey, these are the possible solution for your distributed data storage. If you want highly available and highly consistency, it's possible. Highly available, highly consistency, and highly partition tolerance, it's not possible. You have to choose. Maybe availability या partial tolerance या availability या consistency, or consistency with availability or consistency with partition tolerance. So you have to be clear, mention, talk to the customer. As per the customer agreement, you have to choose two out of these three system design concept: consistency, availability, and partition tolerance. So if you talk basic simple definition of these CAP theorem, so as per the CAP theorem, whatever we already learned, consistency, like every read operation must see the most recent write value or an error something. So whatever if you see any value, this must be updated value, most recent write value. Availability, where every request, whatever the system, whatever the user give any request, they must receive a response with guarantee that's most recent versions. Okay. And third, partition tolerance, say, hey, our system still continue to work or maintain data consistency even some network partitions occur, some breakage out happens, some network failure happen, or you are breaking, partitioning our network to the different locations. In that times, your data must maintain consistency. That means your system still continue even your network partition happen. So in this scenario, as we discuss, consistency have a two option here. If you want to very strong consistency, or maybe eventual consistency are weak. That means all the node in the system see the same data for a given data item. Similarly, eventual consistency or weak consistency, say node may see differ value of given data item, but eventually all node will be have the same. Maybe millions of users going on for the particular data, so might be some period of times this get the updated value and this read the old value, but frequently next minute, next call come, these are eventually going to sync, going to consistent. So sometime we want to strong consistency or maybe weak consistency. Similarly, availability means your system is considered available if it responds to the request in reasonable amount of times. So high availability means system are designed to minimum downtime, ensure the system is always accessible. Maybe you want to serve systems availability means ki all as expected, whenever some request comes, your system is available to respond. But high availability means I'm ensuring that as minimum our downtime, any something fault happens, something problem happen, our downtimes is very low. This is ensuring that your system is highly available. And sometimes your partition tolerance system is considered partition tolerant if it can continue operate when there is a network partition or a split or failure, anything happen, still our system will work. Sometimes, hey, this partition tolerance ensure that system remains functional even some nodes are unavailable or communicate to each other. So somehow any network failure happen, any splitage happen, any network distribution happen, in those scenario also your system should be operated, should be functions. So these three kind of, you can say, key system design concept, but this CAP theorem say, hey, these are the trade-off between the consistency, availability, and the partition tolerance. So you can achieve two of them. Maybe your system can be highly consistent and highly available. You can design such system that is strong consistency and highly available, or you can say strong consistency and highly partition tolerance, or you can say no, I highly availability and partition tolerance, but avoid compromise your consistency. You can say any one of them you have to compromise. So here might be combine the suitable system that require strong consistency and high availability, but maybe not, but maybe may not be tolerated the network failure something. So for example, all the financial or mission critical applications is really required kind of high consistency and high availability. Sometime your CP means ki this is the strong consistency and highly strong partition tolerance, but maybe sacrifice your availability. Here I am compromise some level of availability, but I cannot compromise consistency and partition tolerance. So such is the distributed database. These are the very required high consistency and partition tolerance. But sometimes maybe no, consistency can be compromised, but I need these two, availability and partition tolerance. So this is the suitable for the requirement high availability and high partition tolerance here, but maybe sacrifice your consistency. For example, you are including social media, e-commerce website, or any web application that's really high load, high data, global access application that's go with the AP. So these three, consistency, availability, consistency, partition tolerance, or availability, partition tolerance, you can achieve. So as they mention, just visualize as a symbol. This is your CA or CP, or you can say again AP. These kind of you can things consider, but not all you can three. So let's talk one simple example. Let's in the distributed database, we are going to use your user profile, user data. So all of the possible scenario can be, hey, all the nodes agree to be given the latest version of my user profile. That means the consistency. You can say every request receive the response without guarantee the most recent available. Availability means always you can receive the data, but might be sometime it's not guarantee always you get the recent value, updated value. So maybe system continue to function, maintain data consistency, even the network failure, yeah, any kind of partitions happen. So here in this case user profile I am going to update. So here three cases can be: if a network partition occur, then system may not be guarantee both consistency and availability. But if the system can you can go design some high level consistency, that means it's unavailable for the partition to resolve. Similarly, if you are the prioritize, no, I have a highly availability, then you have to sacrifice the consistency. So somehow means sometimes maybe our users get the old profile, old data, maybe 1 year, 2 requests, 1 year, microsecond and nanosecond delay. After that, you can say your system is become a consistent, eventually consistency available. So while system design sometime very many places, our eventual consistency is a preferable way for the huge traffic, high volume of data. But where any kind of financial data, banking data, insurance data, where data accuracy, correctness is very strictness, then we are going to the high consistency, strong consistency available application. So here's a simple CAP theorem. Basically our any distributed systems where you are going to decentralize your data storage, means whatever data you're not storing only one place, means multiple places. So So generally on those kind of applications, maybe distributed database, you have to think this CAP theorem can be help you to design cloud storage systems. Also thinks how to ensure the CAP theorem, and similar distributed file systems also, and any real-time analytic applications where you have a providing some insight very really times. In those scenario also we have to talk this CAP theorem. So there are some you can say talks good heavy big players are already implemented this CAP theorem, you can say. If you talk about the Google big data big tables, so this is the distributed database that sacrifice the availability, but they can support consistency and the partition tolerance. Similarly, if you talk about the DynamoDB, Amazon, this is also distributed database, but they sacrifice the consistency, but they are offer very highly availability and the partition tolerance. But here you can say eventual consistency they can offer you. Similarly, Apache Cassandra, as I discussed, this is a distributed NoSQL database. They also offer very available, highly available and highly partition tolerance system, but they support the eventual consistency, meaning strong, not a strong consistency, but the weak consistency. If you talk the Microsoft Cosmos DB, this is the global distributed database services, and they have prioritized consistency and availability. They are avoid our partition tolerance. You can say, hey, Cosmos DB consistent and highly available. If we talk similarly Oracle Cloud, here the relational database, they hey, I good the consistency and availability, because I say Oracle Cloud say whatever my database, I am say always consistent and always available, but I am not guaranteed. Maybe I am compromised. Sometime our partition tolerance happens, something network failure happens, something sometimes our system maybe not operate. If operate, if available, they returns correct data, consistent data for every users. So depend upon the use case, big player also offering your CAP theorem already implemented. If you talk the real applications already which are, you can say, already using this concept, somehow sometime I stop my so sometime these kind of applications we start, like if you talk about the WhatsApp applications, this is the messaging apps that use the distributed database to store the messages, right? So here WhatsApp application prioritize the availability and the partition tolerance over the consistency. So here WhatsApp application say I am always try to available and manage the partition tolerance over the consistency. Our data sync, our data message would be available for some delay, microsecond, millisecond decay, but I am always be available. So it's say, hey, so the purpose is that it's allow even the poor networks, still our connectivity is not so good, network is not good, so good, still WhatsApp say, hey, my system is available for you, don't worry. Message send, maybe other user distributed networks, maybe little bit delay, we are going to ensure the consistency, but eventual consistency. Similarly, we talk about the Amazon, the e-commerce platform application. This is the use also distributed database to store customer data, and Amazon prioritize the consistency and availability over the partitions. Here say Amazon's distributed storage, hey, I am going to consistency and availability. I always available and I can provide the actual consistency, always strong consistency. Maybe sometime our application is not available for some network issue, some known bandwidth error, but I am not compromise the consistency or availability. Even you look the Google Map. Google Map also is the distributed database, and here they storing all the map data. So here Google Map what say I am always available even our networks failure or networks low networks no bandwidth. So here say I can avoid my consistency, but availability and network issue partition change happen, I am not compromised. So depend upon the nature of applications, you can say these consistency, availability and partition tolerance are used. So here say Google Map say I am going to Google Map always works, always available, even the remote area where your internet or network is very slow or poor network connectivity, is still Google Map prioritizes of maps can works. Data sync is data storage. I can store, I can maintain consistency with the is eventual. That's no problem. But availability and partition tolerance I cannot avoid. So whenever you are designing any such system for any customer, you have to ask, you have to discuss these kind of challenges. These are the very good concepts of consistency, availability, partition tolerance. You cannot say hey everything will be available, because these are the some technical challenges available. We cannot meet each and every for every scenario. So depend upon the use case, depend upon the applications, we need to compromise some level of consistency or availability or partition tolerance. So these are the very good example applications in really nowadays we are using, they have implemented this CAP theorem. So whenever you are going to designing such systems, please be ready to use CAP theorem or talk to the CAP theorem. Consistency, availability and partition tolerance. You can commit, your system can be consistent or available, highly available at a times. Yeah, your system can be consistent or the partition tolerance at a times. It's okay. Or you can say your application can be highly available or can be maintain partition tolerance. While system designing, we should know first these are the challenges, these are the problem, what we can offer, and while discussing with the customer, feel free to explain, hey, this is your business domain, this is your requirement, and this is the suit for you. Might be sometimes customer not aware these kind of so more technical details are problem, but we already launched lots of use cases, lots of reference application, already application working on this environments. So we have to give the example, talk them, show the reference documents, and then convey, hey customer, this is your, if your data is very volume, your application is very big, you cannot avoid the highly availability. Let's avoid maybe consistency, let's avoid the partition tolerance, but I cannot avoid any kind of a highly available system. Maybe in your limited user base, limited application, okay, hey, I cannot avoid my consistency, I can compromise availability for some period of time, for some downtime, it's okay, it's manageable. So nature of the customer requirement, you have to propose your system designs. While system designing, please keep in mind these CAP theorem as well as. So hope this information help for